Hello, hi everyone, welcome back to the channel. So today in this video we'll be solving this problem, capacity to ship packages within D days, which is a Leetcode medium problem. Okay, so let's read the problem statement. A conveyor belt has packages that must be shipped from one port to another within days. So this days is basically a variable which will contain some integer value representing the number of days which we have, in which we want to port packages from we want to ship packages from one port to another. The ith package on the conveyor belt has a weight of weights I. So weights I basically represents the weight of the ith package, where this weights is basically an array representing the weight of the packages that we have. So each day we load the ship with packages on the conveyor belt, and the order of the packages in which we load them is given by the order in the weights array, and the weights array has a length of n. So we have total n packages. We may not load more weight than the maximum weight capacity of the ship. So a ship has a capacity, let's call it C, capital C, and we can't load packages which exceeds this capacity. Okay, so what do we have to do in this problem? What do we have to do in this problem is that we would return the least weight capacity of the ship that will result in all the packages on the conveyor belt being shipped within days. That means we want to ship all the packages that we have given by the weights array, and we want to ship them from one port to another within these number of days. And for that we want a ship, and we want to find the minimum capacity of the ship that we must have so that we can do the job. Okay, again the same pattern, we have to find the minimum weight capacity of the ship such that all the packages are delivered from one port to another port within the given number of days. Fine. So whenever you see this kind of pattern, try to think about binary search. There are high chances that the problem will be solved by binary search. Okay, there are some cases when we have to use dynamic programming in some problems where we have to find some minimum or maximum, but just a thought process. Try to think about a binary search. So let's better understand the problem statement using an example. Okay, so here we have our example. This is weights array and it has a length n, and n here is 11. So we have 11 packages that we want to deliver from, let's say, port A to port B, and we have 5 days. We want to deliver them in 5 days. Now we want a ship. Okay, so we require a ship. So using this ship we will load these packages, and this ship will transfer these packages from port A to port B. Okay, so now we want to determine the minimum capacity ship that we have to buy or we have to use, so that within these days I can port all my packages to the other side. Okay, that's what I want. So the answer here is basically capacity. Capacity is the answer, the capacity of the ship. That's my target answer. Now for this test case we'll need a minimum of 15 units of capacity. That means the ship must hold a weight of minimum 15 units so that all of these packages can be delivered to the port number B within 5 days. Let's see how this will work. In the very first day I can put package number 1, 2, 3, and 4 as well, because 1 plus 2 plus 3 plus 4 will give me 10. While I can also ship fifth package, that means I can ship these 5 packages on the very first day, and the weight of these 5 packages is 15 units, which is exactly equal to the weight of the ship that we have. So we transfer first 5 packets to port number B on the very first day. Now we have 4 days remaining, and the packages that we have left are these. Now on the second day I can ship package number 5, that is this one, package number 6, that is this one, which has a weight of 6, and the package number 7. These two packages can be shipped because the weight will be 7 plus 6, that is 13. We can't ship 8th package with them. Why? Because if I ship this, then the capacity will be 13 plus 8, that would give me 21, but the ship capacity is 15. Okay, so put 6 and 5 into the ship and deliver them. So they are also delivered. We are left with 3 days only. Now let's ship the next packages. Next packages has weight 8, and the ninth package has weight 9. I can't ship both of them in a single round because that would give me a weight of 9 plus 8, that is 17, and this is not possible. It is not possible to ship packages with weight 17 in the ship which has a capacity of 15 units. So we put only package number 8 and we deliver it. So we have 2 more days remaining. Now in the 9th day we ship 9th packet. We have 1 day remaining, and on the 10th day we ship 10th package, and that's all. We take exactly 5 days to ship my packages, and I'm claiming that 15 is the minimum capacity that I need. Can I do it in a ship of capacity 4? Let's check it. And I'm saying, okay, let's say if I can do the same job using a ship of capacity 14. Now I can put first, second and third package as well as fourth package on the very first round, because they sum up to give me 10 units of weight. Okay, so these are shipped, they are transferred in the very first day. So we have 4 days remaining. Now on the second day we ship these 2 packages, that is package number 5 and package number 6. So we transfer 11 units of load from A to B, and we have 3 more days remaining. Now next day, on the third day, can we ship these 2 packages, that is 7th and 8th? No, we can't, because their weight is 8 plus 7 is 15, while the capacity is 14. So we will only ship package number 7, that is this one. So we have 2 more days remaining and 3 packages remaining, that is package with weight 8, 9 and 10. Now let's try to transfer package number 8. Yes, okay, so that let's try to transfer package number 8 and 9. We can't put them in, we can't put them together because their combined weight will exceed the capacity. So we put packet number 8 and we transfer it, and we have only 1 more day remaining, but we have 2 packages whose weight is greater than the capacity of the ship. So we can't transfer them in a single day, and it takes us a whole day to transfer the packages from position A to position B. So 14 is wrong. We can't use a ship of capacity 14. Hence the answer is 15. This is the very first answer, or this is the minimum integer or the minimum capacity which we have to use to transfer the load from position A to position B. Okay, now also the cargo must be loaded in the same order. So we are given an array, the cargo must be loaded into the ship in the order given in the weights array. We can't put the cargo like put packet number 1, put packet number 5 and let's say packet number 8 in a round. We can't do so. We have to put 1, 2, 3 in this order in which we are given in the weights array. We can't split them according to the capacity. Okay, so that's the constraint. Now let's try to build the solution. Let's try to build the solution for this problems. As we can see that we already know that the problem will be solved by binary search, but let's see how and on which variable we have to use the binary search. We can see that what do we want to do is to find the minimum capacity, and minimum capacity is basically the answer. So we want the capacity is the answer. Let's denote it by capital C. Let's say capital C is the answer for our problem. Let's say for this problem we have 10 packets and we want to transfer them in 5 days. Let's say we need to use a ship of capacity C. Now I'm claiming that this is the ship with the minimum capacity which I have to use. That means I can't use a ship with capacity C minus 1. I can't use a ship with capacity C minus 2. I can't use a capacity with ship C minus 3. But I can use a ship with capacity C plus 1. Although it's not the answer, but I can use it. I can use a ship with capacity C plus 2. And so on. While this is my answer, this capital C. Okay. So how would I find this answer? So this is the I'm trying to build my search space. As we do in these kind of problems, we have done this many times in the previous videos. I'm trying to build a search space for my answer variable. The answer variable is the capacity. Now on the left extreme, think about the case, or think about a ship which has the minimum capacity. What minimum capacity is allowed so that our ship can transfer weight? If you think carefully, then you can see that in this array 10 is the weight, 10 is the item with the maximum weight. This item has the maximum weight. In order to transfer at least one weight from position A to position B, our ship must have a capacity of at least 10. Okay, because let's say I want to, the minimum I can go is just transfer at least one item, transfer items one by one. Even in that case I will need a ship with the capacity equal to the weight of the equal to the maximum weight of the item that we have, and the maximum weight is this. So we need a ship of at least capacity 10 units. So on the left extreme I would have 10, or in a general case I would have max of weights, max of this weights array. We simply find the maximum in this array, and that would be my left extreme. What would be my right extreme? What can be the maximum capacity a ship can have so that I can transfer all my items? We can say that, okay, let's say we have a giant ship in which I can put all my items and it will transfer all those items in one day. That means the maximum capacity would be equal to the sum of weights of all the items. Sum of weights array, or items in the weights array. That is my right extreme. So we have our search space from here to from maximum weight till sum of all weights, and this is my answer, capacity. Just run the binary search algorithm, because we have okay, now we just have to run the binary search. Initialize the low pointer to this variable, that is max of weights, high variable to this, that is sum of weights. So this is high variable, this is low variable, and then run the usual binary search, that is guess some middle element, let's call it mid, and now check if this mid is a possible answer or not. If it lies on this side or on this side, so I would say this is a bad, these are bad capacities, because we can't use these ships, and these are good capacities. Okay, now check if mid lies towards bad side or towards good side. If it lies towards bad side, that means I need a ship with higher capacity, so I would search my answer towards right side. That means the search space would be reduced to this one. Let's say mid is here, this is case number 1. But let's say the mid lies on the good side, let's say it lies here. That means I can use this ship to transfer the goods. But I want to find the ship with minimum capacity. I want a better answer. So I will store this as an answer for now, and I will check for a better answer towards left side here in this search space. So high will be reinitialized to this element. Fine. And in this way I will have my answer stored after I run the binary search, after the binary search finishes its iterations. Okay, that's all. Now all we have to do is to check if this mid lies on bad side or it lies on a good side. That is my Boolean function. So what would be the definition of the Boolean function? Okay, so observe some facts that we have to utilize, we have to ship the goods which we have in the order they are given in the weights array. We can't use, let's say, use 1, then use 4, and then pick 7, and then pack them together and ship them. We can't do so. We have to process them in the order they are given in the array. So that basically gives me a good relief. Why? Because all I can do is start traversing items from the very first element and just start putting them in the ships. Put 1 in the ship, then put 2 in the ship, then put 3 in the ship, then put 4 in the ship. Let's say the guessed mid is 14. Let's say the guessed mid is 15. I have guessed 15 as a middle element. Then I will just start traversing the array from the very first element and just keep on putting elements into the ship. Now here I can see that after I put 5 items into the ship, the capacity becomes 15. So the weight that I have loaded into the ship is 15. And this is the guessed capacity that I have. I'm assuming that the ship I'm going to use has the capacity of 15 units. That means at this point I have loaded my ship completely. There is no scope of putting any extra item into it. So at this point I have to say, okay, I have to wait for 1 more day for the ship to load again from the 6th item onwards. Now I have to transfer these items to the other side. So this is counted as 1 day. I have to spend 1 day in transferring these goods to the other side. So now these are transferred. Now the ship comes back and I start loading the items from the 6th item. So I load item number 6, then I load item number 7, then I ask, can I load item number 8 as well? No, because this gives me 6 plus 7, that is 13. If I load item number 8, which has a weight 8 units, it will give me a weight of 21 units, which is exceeding the capacity which we have assumed. So we can't put item number 8 into the ship. We have to wait 1 more day. So we will pack these items, item number 6 and item number 7, into the ship and send the ship to the other side for these packets to deliver there. Okay, now that would take 1 more day. I have to wait 1 more day for the ship to come back so that I can start loading from the 8th item. Now this is again shipped. Now we again start traversing from the 8th item. Now I load item number 8 into the ship. Now can I load item number 9? No, because this would give me 9 plus 8, that would give me a weight of 17 units, and the ship has a capacity of 15 units, so we can't load ninth item into the ship. We have to move with this single item on the other side. So we have to wait one more day, and then the ship will come back, then we will start loading from ninth item. So this is again transferred. Now we put item number 9 into the ship. Now can I put item number 10 in this round? No, because that would give me 10 plus 9, 19 units of weight, which is exceeding the capacity. So I will again move on the other side with this single item. So this would take me one more day. I come back and now I load item number 10. So item number 10 is loaded into the ship. Now I move again to the other side, and that would take me one more day, and all the items are transferred. So this is going to give me 5. So this is not exceeding the number of days. I can see that I want to transfer the items in 5 days, and this ship is taking exactly 5 days to transfer these packets, and I have transferred all the goods on the other side. That means this 15 can be my answer. So I store 15 into the answer variable. 15 is stored into the answer variable. Okay, but since I want the minimum capacity ship, the search space will be reinitialized to low to mid minus 1. Low to mid minus 1, because so that I can look up on a better answer, or a ship with even minimum capacity. So that's how the predicate function will work. Let's okay, and very simple. Transferring the packets in the order they are given in the array has made our job easy. Okay, it is easy to implement the boolean function if the packets are transferred in the order they are given in the weights array. Otherwise we'll have to find the suitable combinations of weights so that we can pack the items in the most optimal way. That would be very difficult to implement. So let's try to implement this solution which we have discussed here in the next slide. Okay, so this is a ship within days function which takes in this weights array and number of days in which you want to ship this weight. Initialize 2 pointers low and high, store 0 in them, and now find the low and the min. Iterate over the weights array. High would basically be the sum of all the weights that we are given in the weights array, while low will be the maximum of the weights we are given. Now I run the usual binary search. I compute the middle element, and I check if this middle element is a valid capacity. So this is valid function which checks if this mid is a valid capacity, or I can use a ship of this capacity to transfer all the goods on the other side within these number of days. If it is the case, then I reinitialize the range to low to mid. Otherwise, if it is not the case, then the range is reinitialized to mid plus 1. So because in this case I need a ship with higher capacity, mid plus 1 to high, and at the end I return this low because this is going to store my first true. This is basically first true. We are just finding the first true element. Okay, and let's see the implementation of this is valid function. Okay, so this is the is valid function which takes in this weights array, the capacity that we have assumed, the middle element, and the number of days that we have. Initialize this c. This is a small c which basically represents the count of the days which we have, and this sum is initialized to 0, which represents the weight that we have pushed into the ship, or that we have loaded into the ship. So now iterate over the weights array. If the sum exceeds the capacity, that means I can't put that item in this capacity, so I have to take another round. So I increment the number of days by 1, and the sum is reinitialized to 0 because the ship will be empty when it comes back, and then add that item into the ship. Fine. So in this fashion, this function is working. I'm just traversing the array from left to right and putting the items till the items do not exceed the capacity, and eventually counting the number of days whenever the load exceeds the capacity. Because to take the extra load, we have to wait for one more day, and that's what I'm counting here. At the end, I will check if the number of days that I have counted are less than the number of days that we are given. If it is the case, that means I can transfer the weight in days, in these number of days which we are given. Otherwise, I can't transfer, so I will return false in that case. Fine. So that's how this is valid function is working. And let's discuss the time and space complexity. We can see that this function takes linear time complexity big O of n, where n is the length of this weights array. Okay, because I'm iterating over this array here, while this is binary search and this is taking log of small n, let's call it m, log of m time complexity, where m basically represents the length of the range, that is high minus low plus 1, high minus low, this range, while the overall time complexity becomes n multiplied by log of m. This is the overall time complexity. Fine. Now let's, okay, so this is not log n, this is log m basically, where m is the size of the range. This is a mistake. While the space complexity is big of 1 or constant, because I am not using any extra space to store anything. Okay, now let's see the code implement of this solution. Let's jump to our Sublime text. Okay, so this is a solution class. Let's implement the minimum capacity function. So let's call it minimum capacity, which takes the weights array, the number of days. Let's calculate the size of the weights array and initialize two pointers. The first pointer is the left pointer, or the low pointer, initialized to 0. High pointer initialized to 0 for now, and let's iterate over this weight array and find the maximum element in this weights array, which will behave as the lower limit, while sum all of the elements in the weights array, which will behave as the higher limit. Okay, now we have our low pointer and our high pointer. Let's run the binary search. High, find the middle element, low plus high minus low divided by 2. Check if it is valid. So if it is valid, I would pass the weights array, I would pass the middle element that I am assuming, and the days that we have. If it is valid, then reduce the search space to the left half, that is mid. Otherwise, reduce the search space to the right half. And at the end, this low will store my answer, or the first true element. Let's see the definition of this boolean function, that is valid. Bool is valid, which takes in this weights array, the middle element, or let's call it capacity, that we have assumed, and the number of days that we have. Let's initialize a variable sum to 0 and iterate over the weights array and check if sum plus it is greater than capacity. If it is the case, then we have to count the number of days that we have. So we have to take the another variable. Let's initialize it to 1. That means we have to take at least 1 day to transfer the goods if we have non-zero weights. Now it will be incremented by 1 because we have to wait for yet another day to ship this packet with weight IT, and the sum will be initialized to 0 and put this item into the ship here. That means add IT to the sum and return if the number of days that we have taken to transfer the goods are less than the given days. If it is the case, then return true, otherwise return false. So that's all. This is the implementation of the solution in C++. Let's see the implementation in other languages. Okay, so this is the implementation in Java, and this is the implementation in Python language. So that's all for this video. If you like the video, then hit the like button and continue with me in this binary search series. I hope you are learning something new and you have upskilled till now if you have followed this series. So stay with me for more such discussions. I hope to see you all in my next video.